Welcome back. We are now going to talk about the second of 3 assigned practice free response questions for AP Physics C Mechanics as we end our forces unit. Again, if you have not tried this already, please pause the video and try it. It really benefits you a lot to try. It's okay to not get it perfect. It's okay to actually struggle, right? It is still November. Use this time to continue to improve. All right. Otherwise, I'm going to assume you're ready to go, and let's rock and roll. We're told we have an Atwood's machine that consists of 2 blocks connected by a light string. Light here means massless, so when you read this term light, what they are saying is massless, over a frictionless pulley of negligible mass, right? So this is not a rotation problem. The masses of the 2 blocks, M1 and M2, can be varied, but M2 is always greater than M1. All right, so there are lots of key statements that they're saying here, and again, it's always important to take the time to track these things. The fact that it is a light string over a frictionless pulley of negligible mass means that we can disregard those things. This is just a Newton's third law and Newton's second law problem. The other thing is that M2 is always greater than M1, so the system will be unbalanced. Right, that means that we will always have acceleration on the M2 side that's down and A that is up on the M1 side. And so net force will be down and net force will be up, following Newton's first law. So we are asked on the dots below, which represent the blocks, draw and label the forces, not components, never draw components, that act on the blocks. Each must be represented by a distinct arrow starting on and pointing away from the appropriate dots. So for those of you who have taken engineering, please be careful. The relative lengths of the arrows should show the relative magnitude. So remember in the first problem I said that they didn't want that because they didn't give you a scale. Now they have given you a scale. All right, so I'm going to start with M2. M2 has a greater mass and so a greater weight than M1. And we said that M2 needs to accelerate down. So the only other thing acting on M2 is a tension force, which will be up, but must be less than M2G. So I'll make it 2 lines long instead of the weight, which is 3 lines long. Now, by Newton's third law, if the action is over here, since it's a massless rope and a massless frictionless pulley, then the reaction force will be over on block 1. And remember that the acceleration over here is up, so M1G I have to make really small to show the unbalanced forces on the other side. All right, we'll look at the scoring in a minute. Let's talk about B. Using the forces in your diagram above, write an equation applying Newton's second law to each block. So notice they don't want us to do the thing that we've talked about, which is making both blocks together one system, and using these equations to derive the magnitude of the acceleration and show that it is this equation. So they want you to derive. So we talked last problem about this word derive. Derive means you can't just write the answer. You must show all of your steps as if you're writing a proof or as if maybe you're the teacher teaching the class, right? Assume that the grader doesn't know how to get there and you must show all of the steps. So the sum of the forces on the Y on mass 1, this is where you have to be careful. For mass 1, I'm going to make positive Y up. For mass 2, I'm going to make positive Y down. I always like to make the acceleration positive. So the sum of the forces on Y1 equals Ft, which is positive, minus M1G equals positive M1A. And we want to note that A of block 1 equals A of block 2, which equals, we'll call A. No vector symbols, I'm just talking about magnitude. Right. The sum of the forces in the Y on block 2 is going to, now we have to be careful, right? Positive Y is down. So it is a negative Ft plus an M2G equals a positive M2A. So we have a system of equations. Notice that one thing that's not present in this final answer is an Ft. So I must solve for an Ft. The easiest one to solve for is this one. So I'm going to write from here that Ft equals M1A plus M1G. don't factor out the m1 yet, or you'll make your life harder. What I need to do then is substitute. So now I can rewrite this equation. I have a negative that I have to distribute, right? So negative m1a minus m1g plus m2g equals m2a. So now I need to gather like terms, remove the common factor, and divide. Boo, boo, doo, boo. Gather like terms, remove the common factor, and divide. Boo, boo, doo, boo. So what I need to do now is get the a's on the same side. So I'm going to keep the m2g minus the m1g, just rearranging because I don't like starting with negatives. Maybe I'm weird, I don't know. And then m2a, and I need to add m1a to both sides, so I add an m1a to both sides. We would factor out the a, and so I can write that, and notice I can factor out a g here, so I can take the g out, multiply it by m2 minus m1. That looks like above, that's good. And I'm going to divide by this m2 plus m1 times a. That would form over here, divided by m2 plus m1 equals a, and we're done. All right, let's go ahead and take a look at the scoring for that. And we'll see again that really you can bank a lot of points with the free body diagrams and the equations. So between A and B, there are 6 total points. For A, for correctly drawing and labeling the vectors for the weight of the block and the tension for block M1 with the tension larger than the weight. So you have to draw and label these, and you have to have them unbalanced. For correctly drawing and labeling the vectors for the weight of the block and the tension for block M2 with the weight larger than the tension. So again, this force has to be greater than this one, so the acceleration is proper. For correctly drawing the tension on the 2 blocks is equal in magnitude. So even if you goofed up having things unbalanced properly, if you apply Newton's third law correctly, you earn a point. If any extraneous vectors are drawn, so if you did a third force on either of these, only a maximum of 2 points may be earned. So careful. All right, for the next one, 3 points for correctly applying Newton's second law to block 1. So if you write Newton's second law, now it says correctly applying, so that means it must be correct here. If you wrote negative ft plus m1g equals negative m1a, so if you flip the signs, you still earn the points. So don't be upset, don't be stressed if your signs are backwards. As long as you have the equivalent thing for each of these, you earn the 2 points, just like we did there. All right. Then for combining the 2 equations above in such a way that will lead to the correct equation. So you have to write these 2, and then you have to combine them in a way that would lead there. So what that means is you don't actually have to simplify, I guess. You just have to write this sort of thing and then say, aha, that is what we were asked for. Okay, so those are the first 3, those are the 6 points. Now, the average I wrote was 6.3. So basically, a lot of folks, I just totally bombed the next part, which is tricky until we practice graphs enough that you really start to be comfortable with this. So graphing is usually a part of one of the 3 problems on the AP exam. I'd say 2 out of every 3 years, and I don't think it was a problem last year, so it's probably going to be a problem this year. And it's just really good to be comfortable identifying how to make graphs. So let's look at this question here. The magnitude of the acceleration A was measured for different values of m1 and m2, and the data are shown below. Indicate below which quantity should be graphed to yield a straight line whose slope could be used to calculate the numerical value for the acceleration due to gravity g. All right, so this is where you have to become adept at taking equations and seeing how there's a linear setup here. Right, so our equation was A equals, and they even tried to write it in a way that helped because they put g at the end, m2 minus m1 over m2 plus m1 times g. All right. So what we want is a y equals mx equation. right? We need this x to the first power, and we want g to be slope. So what you do is you write the equation like I did, and notice the one side has one variable, so a will be the y. So vertical axis will be a in meters per second squared. And then for the next piece, we have, we want g as our slope, right? What would give us a slope that would let us find g? So m, I want to be g. Now, you could do a few different combos perhaps, but I'm going to show this one because this is the simplest. Make m g, and so this whole thing would be our x. This whole thing is what we are changing. So our x is going to be the quantity of m2 minus m1 divided by m2 plus m1, which would be unitless. So we have to indicate that. Now we have to plot the data points. Clearly scale and label all axes, including units, if appropriate. Oh, that's a big hint right there. That's a big hint right there. So on the vertical axis, we said A in meters per second squared. For this one, I'm taking mass, which is in kilograms, and dividing it by mass in kilograms. What happens to the units? They divide out. So this is unitless. But we still need to label what it is that we are doing. Be careful of PEMDAS, right? And then what we need to do is plot. Now, for the sake of brevity and for the fact that plotting on a touchscreen I find to be near impossible, let's just look at the solutions here. So notice they plotted what I suggested. First, for C, there is 1 point for indicating variables that will create a straight line whose slope can be used to determine G. So they did what I did, A, and then M2 minus M1 quantity divided by quantity of M1 plus M2. Full credit is earned if you flip-flop these or if you used another acceptable combination. So it's really hard to think about what those combinations are for me. Basically, if you did something weird and you want to know if it's right, just send me an email or stop by and we can talk about it. All right, for using a correct scale that uses more than half the grid. So did you use more than half of this paper? If no, you don't get that point. You have to also correctly label the axes, including units as appropriate. So these labels are a point, plus the scale. So I really think that's something that's earnable. For correctly plotting the data, and for drawing a straight best fit line consistent with data plotted. So remember to plot your points and then draw a line of best fit that goes through the middle as much as possible. One key thing, notice they've given you space here to calculate new things. It says use the remaining tables as above as needed to record any quantities. Now, it takes a long time to punch in M2 minus M1 divided by M2 plus M1 unless you use a graphing calculator. So this is another time to highlight. Remember we talked about you can go to Stat, and then you hit that Edit key. And in that, make L1 M2, make L2 M1, and then set L3 equal to M2 minus L1, so L1 minus L2, divided by L1 plus L2, and hit enter. And if you do that, you save yourself so much time. My guess is a lot of students didn't score well on this because they ran out of time, because calculating this step by step would take forever. Right, doing that 5 times, oh my goodness, that would just, like, if you are in that situation and you have forgotten this and you're thinking of doing this, please just skip it and come back and do this later. Right, the graphs are at times a great way to gain a lot of points, but they can be such a time sink for students. I just feel so terrible that you know your physics, but you get lost in the graph and you end up not doing well. So only do the graph if you have the time. Otherwise, just move on. Come back later. All right. After you plot your data, point for correctly calculating the slope using the best fit line and not data points unless the points fall on the best fit line. Or credit may be given for the linear regression only if student states linear regression is used. Okay, so you still have to graph anyways. You might as well just show your work and get the slope point. And then for correctly relating the slope to g, so basically just saying g equals slope, which is my number with units. All right, and then that's it. So this can be a relatively simple question, or it can be a relatively complicated question if you don't see the whole how is it that I make my plot linear. So we will continue to practice this over and over. You really want to practice writing y equals mx and thinking about, okay, for this equation, what's the m that I want? It's really here. And what's the resulting x that's left? It's all right there. And if you keep practicing that, it'll click, and these will be really nice questions for you. And if you don't practice, it becomes really challenging. So that's it. Thanks for watching. Don't forget to complete the reflection for your additional credit, and have a great rest of your day.